So again, you completely have it under control, and the administrator cannot do anything. The only thing he can do is by collecting the nodes, okay, thousands or millions of nodes, and then reprogram them. So the code you are putting here, okay, it's this one. Okay, this is the worm. Okay, instructions 1 to 37, okay, are actually the commands that are used for broadcasting itself. Actually, this is the self-replication. Okay, and this here is the malware, okay, that you can write. Okay. We can show an example. I have written a malware, okay, that actually plays with the LEDs. Okay, just 10 rows of the green LED. It's a simple jump command, but I'll show it afterwards, because if I do it now, then you cannot show anything else. Okay, the final thing is I have this network data injection, okay, which is obviously for injecting data in fake application messages inside the network. Okay, so this is a snapshot. You can inject all kinds of application messages, and actually you can inject all kinds of routing messages. Okay. Now this is again extremely severe, because you can have this hello flood attack. Since you have a strong antenna, okay, for example, in my node that I have attached to the laptop, I'm using a range of 15. Okay, this is the maximum range. So imagine that this is stronger than the other sensor nodes. So you can inject a routing update from a node that doesn't exist. Okay, so you insert ghost nodes. So this is kind of like something like kind of sinkhole, but you are saying to the other nodes that there is a node that exists, let's say ID 7, okay, but it's a ghost node. So all of the other neighboring nodes, okay, will choose the ghost node as their parent. So they will send their messages to nowhere. Okay, all the messages will be lost. Okay, and eventually the administrator will go crazy. Now, before we do, if I have time, some demos, okay, some fair questions about the tool. First of all, and the most important, I think, is that if I have tested the tool against real deployed networks. Okay, when I started building the tool, most probably, and it's obviously that I do it against these toy networks. Okay, but when I managed to do most of the attacks, okay, I tried it against real deployed networks. Okay, first of all, my attack was in a network that was created by a university for the WWF company. Okay, I told the guys that I want to test it, so they had deployed the network that was consisting of 250 nodes on an island. Okay, they were monitoring some turtles' movement and all this stuff. So I went over there and I used not the hardware but a really strong antenna. Okay, and I tried to attack the network. So I performed all of the attacks, not the malicious code injection, the one because I hadn't created that time, but the sinkhole, the data injection, and everything worked. Actually, because they have placed the nodes in specific positions in order to have the range, but to put it in the limit, okay, not close enough, because they wanted to put 250 nodes in a really big island. So they chose the position of the nodes. So the ranges were not that were big, but they were not, the link quality is not that good. So by doing the sinkhole attack, eventually I caught, I think, 180 nodes of this 250, forwarded the messages to my tool. Okay, so it was working, the attack tool was working really well. And actually I've done some attacks in conferences, in other people, presentations. And again, this shows that the tool is working. Now, what sensor platform hardware okay, I'm targeting? I have tested it with T-modes, Mika 2, and Fireflies. Fireflies are extremely important in sensor networks. But the thing is that this tool works, it's independent from the sensor platform hardware, because we are targeting the underlying protocols, okay, the vulnerability of the protocol, not the hardware. Okay, the hardware, you must know it in order to find the addresses if you want to do some code injection. And again, this is not for the hardware, this is for the program image. But okay, if you compile it for a T-mode, let's say, and compile it for a Mika 2, they have different memory addresses. But it's independent from the sensor hardware. Now, what happens in case of strong security protocols? Obviously, okay, some of the attacks are not going to work. For example, okay, my main research is on security on wireless sensor networks, so I have created also an intrusion detection protocol. Okay, this is what motivated me to build the attack tool to test my intrusion detection protocol. Okay, so all of the routing attacks, sinkhole attack, data injection are not working because of the intrusion detection. But the malicious code injection, okay, I haven't found any way yet, and I haven't found any actual defense mechanisms against code injection in sensor nodes. So the malicious code injection, which I think is the most destructive, still works. Now, is it extendable? Obviously, you can have the source code, you can add messages, you can add attacks. And next week, I think I'll upload also the source code of the tool. So if any of you like this tool, he can download it. You can download all the libraries that are needed to run this tool. Play with it. The important thing, if we find any bugs, I will please to report them, because it's too many lines of code. And if you can add new attacks or new message structure, again, they are more than welcomed. This was it. But if I have, let's say, 2 more minutes just to show you the code injection. Now I have written the code of the worm inside the text file. Now this is the whole code of the worm. So we have this instruction, as we said, from 1 to 37. It's actually the self-replication thing. And then I have added some more packets, just for playing with the green LED, as I told you. The code for the self-replication is 166 bytes. This is default. So you need 28 packets for this piece of code. All the other messages are for the malware, actually. I have 11 more packets that I'm sending for playing with this LED. Now, if you start the transmission, now this is not supposed to be so slow, so it's really fast. If you do it through the nodes, but I have put it a delay in order to be able to see the messages that are transmitted. You can see it's started to transmit 39 packets. And you can see the payload of each one of the packet. So as you can see, this 41A in each packet is the address, of the stored, where they store the packets. So you send 38 packets. The 39, the last one, is actually telling to the program counter to go to where I store my packets. So I store it in memory address 2547. So you are seeing that the node, the attached node, starts broadcasting the messages. It's not possible to see it now. So eventually, now that it's finished, they start transmitting the malware itself. And once they finish the transmission of the malware, some of the nodes will play with the green LEDs. And this over here is the network data injection. Obviously, when you run it, if some of you download it, do it in a higher analysis than this one, because it will not work. And this was it. I don't know if you have any questions. Thank you.